Hey guys, good evening and thanks for joining. So in the last class, we discussed about difference between router and switch, and also when we can use switch and when we can use router, and what is the functionality of the switch and what is the functionality of the router, and also what are the drawbacks of the respective switch and also router. These things we discussed. So next topic is we discussed about TCP flags. We discussed about 6 TCP flags. So that's all we discussed yesterday. In the today topic, I'm planning to explain TCP IP layer versus OSI reference model. So before class has been started, I was making this particular table. Now we can go and we can discuss. So TCP IP reference model is advanced version of the OSI reference model. And what is the practical use for TCP IP reference model? So whenever any troubleshooting purpose or debugging purpose, if you want to troubleshoot, so for example, maybe in the practical scenario based, packet capture analysis, and also whenever any logs are onboarding to SIM tool, but it is not reflecting, any networking related issues are occurring. Maybe flooding category of the issues or spoofing category of the issues are happening, but we don't know where is the issue. For those scenarios, normally we will analyze TCP IP layers only. So these are all the practical scenarios or use cases where we can use the TCP IP layers. And what is the importance of the TCP IP layers? So let's start here. TCP IP layers. So full form is transmission control IT protocol layers. And use our practical scenario when we can use these particular TCP IP layers. Use case or practical scenario. Network traffic analysis. In the similar way. Second point is debugging and troubleshooting purpose related to network or application or else network interface. Where is the exact issue? So for example, take maybe 1 week back or 2 weeks back, Microsoft global outage, it is appeared and it has a lot of business impact. In that particular scenario, so what is the analysis they have done from the respective Microsoft side and also CrowdStrike side? They have NOC team, NOC, Network Operations Center, and the second one is called SOC, Security Operations Center. So NOC, what is the difference between NOC versus SOC? So NOC team mainly they will take care of the network issues identification and also server related issues identification. In the similar way, application related, performance related identification. So those things they will monitor. So that is called NOC. So full form is Network Operations Center. So these team they will take care of mainly 3 things. That is called NPM. Second one is called APM. Third one is called SPM. So what is meant by NPM, APM, and SPM? So NPM full form is Network Performance Monitoring. So APM full form is Application Performance Monitoring. So next one is Server Performance Monitoring. So these 3 validations are monitoring 24/7 into 365 days will be done by NOC team. In the similar way, SOC, Security Operations Center, that is nothing but our team, cyber security team. So they will take care of the security monitoring. So 24/7. So that is the main difference. So why I'm explaining this one NOC and SOC now? So whenever any network related issues will occur related to outage, and also application related issues will occur like client side errors or server side errors or backend database side errors like 100 series, 200, 300, 400, and 500 HTTP authentication codes basically. So those scenarios, application performance monitoring part and server performance monitoring. Whenever any server CPU utilization, RAM utilization, or bandwidth utilization is crossing the baseline 70%, automatically alert has to trigger. So this is the baseline most of the organization will follow. So most of the case as compared to SOC team, NOC team will do packet capture analysis more. So if you want to do the packet capture analysis, will not follow OSI reference model. We'll follow TCP reference model only. So in between the source and destination, wherever the issue is existing, we can trace that particular issue using TCP IP layers. And TCP IP layer contains 4 layers. So this is one of the practical scenario. On the NOC side, anyway, topic has come. So I'll explain a couple of tools as well. What are the different types of tools will be used by NOC? So example tools from the NOC side. So first one is Riverbird. So it's one of the famous tool all over the world. It's number 1 as per Gartner report. And also next one, we have Fluke Networks. So this is also one of the very, very famous tool from the NOC side, not SOC, NOC. SolarWinds. So this is also one of the famous tool. This particular tool is got compromised last year, 2023, sorry. It is one of the biggest disaster it's happened, whoever is using part of the SolarWinds tool. So that particular product itself compromised by the attacker. Next one, we have WhatsApp Gold. Not our WhatsApp, WhatsApp Gold. In the similar way, we have PRTZ. So there are so many. Cisco Manage Engine. So these are all the couple of tools will be taken and monitored by our NOC team, Network Operations Center. These scope will not fall under us. So they will take care of the network performance monitoring, application, and also server. So that is about the NOC overall roles and responsibilities. So there also they will take care of the any outage related issues will occur, whether any half duplex or full duplex, whether switch went down or router went down or load balancer went down, how the traffic is balancing by the respect to load balancer, and what is the application availability related issues are occurring. So client side related issues are occurring or server side, along with the application support team, they will work. And in the similar way, so server side, is there any performance or outage or availability issues will occur? Those things can be monitored by our NOC team. Okay, so as compared to SOC, as I said previously, whenever if you want to do the network debugging or network troubleshooting part, we have to do the packet capture. After doing the packet capture, this is also called a TCP dump if it is server case. And after taking that particular packet capture, we have to go and we have to import that particular packet capture file part of the Wireshark or Microsoft Network Traffic Analyzer. Thereafter, we can go and we can do the analysis. Whenever if you want to do the Wireshark analysis or packet capture analysis, so in that scenario, it will not give the YSA reference model. It will give the TCP IP layer reference model only. So that is about overall background. What is the importance of the TCP IP reference model? So now coming back here, there are 4 layers under the TCP IP. One sec. There are 4 layers part of TCP IP. So those layers are first one. So I will come like a top to bottom. Fourth one, application layer. Next one, transport layer is called as the transport itself. Next one is, second one is internet layer. So this is also called as network layer. If our, so comparing with our voice reference model. And finally, network interface layer. or network Ethernet layer. So these are all the 4 layers will fall under the total TCP IP reference model. Now what I will do, I will combine first 3, application, presentation, and session. So these are all the OS reference model. And so here I'm keeping TCP IP reference model layers along with that one data format. So application, presentation, session combining together, we can call it as application layer. So on data format is data only in these 3 layers. So all the man in the middle attack, session hijacking, WASP top 10 category, authentication failures, authorization failures, broken authentication, broken access control, insecure design, all those attacks will fall under the respect to application layer. So transport layer is transport itself. It will not change any name. And data format is segments or datagrams. So that is about a transport layer. And so you know already what are the different types of category of the attacks will fall under the transport layer. So we have TCP flood, sync flood, UDP flood. So those flooding category of the attacks will fall under the transport layer. So next layer is called as internet layer. So why we have to call network layer as internet? Why? Because using router in the network layer will get the internet. That's what we discussed yesterday as well, and the day before yesterday also. So in the network layer only we'll get the internet. That is the reason network layer is also called as the internet layer. And so data format is IP packets here. And a couple of attacks will fall under this particular, okay, so part of the network layer or internet layer or IP spoofing. In the similar way, ARP poisoning or ARP amplification attack. In the similar way, ICMP flood attack. So ping of death attack. Okay, so IP flood attack, all those attacks will fall under the network layer or internet layer. So last 2 layers, if you are combining in OSI, that is nothing but data link layer or physical layer, then we can call it as a network Ethernet layer or network interface layer. So most of the cases, whenever if you're configuring any network devices, as I mentioned several times in the class, like a router, switches, load balancer, hub, or firewall proxy, NDR tools, network IDS, network IPS, each and every tool has a Ethernet interfaces. So we have to configure those Ethernet interfaces. Then we have to give physical cable connectivity if it is on-premise or data center. If it is a cloud, just we have to configure the respective interfaces. So I have shown practically already which contains the couple of Ethernet interfaces, SIM tool, and also EDR, firewall, proxy. Every tool contains the basically all these interfaces. First, we have to configure the interface, whether it is a layer 2 mode or layer 3 mode or else high availability mode. Thereafter that, we have to give the physical cable connectivity based on the network architecture diagram. So that is the reason we have to combine together these 2, data link layer and physical layer. Finally, we can call it as a network Ethernet layer or network interface layer. So coming back here, what is the data format in the data link layer? It is called frames. And also what are the, okay, so physical layer data format is raw bits, nothing but 0 or 1. So that is about, so TCP IP reference model and how many layers are there and so on. So which tool can be used to analyze the packet analysis or packet capture or TCP dump analysis? So I will give one more practical scenario also here. Additional use case. SIM2 log onboarding. That is our main SOC tool. And also firewall packet capture analysis, network IDS, network IPS packet capture analysis. So proxy or load balancer. So load balancer is LB or load balancer. Not only this one, even routers, switches, and anything, if you want to make sure that where is the exact issue, so then we can do the packet capture analysis and we can analyze this one. Why I'm stretching this particular topic very, very importantly, because it's one of the favorite interview question. Do you have any experience on Wireshark? In the Wireshark, what exactly you will do? Okay, so it's the implementation level, it's a troubleshooting level. So basically, so now coming back here, so example tool for packet capture analysis, either is Wireshark or else Microsoft Network Traffic Analyzer. So out of these two, once again, which one is very famous is Wireshark. So where can we download Wireshark now to do the network packet capture analysis? So just you can go to Google and you can type Wireshark download. Can you see my screen? Can you see my screen?
Yes, sir.
Yes, yes, sir.
Sir.
Yeah, Wireshark, this is the website basically. So now whatever operating system you are using, whether you are using Windows or Mac or Unix operating system, you have to download that particular so tool. For example, I'm using Windows 64-bit number. What I have to do now, I have to download this one. Okay, after downloading this one, I have to install this Wireshark tool, and the latest stable release version or general availability version or public availability version is 4.2.6. Now you can see here, they mention one more thing here. You can also download the latest development release 4.3. Nothing but that is right now in beta version. As part of the software development life cycle, it is still in the development environment. It's not released to the public or general availability. After doing the user acceptance test or maybe so testing thing, finally they will release to the public. Okay, so this is the way how we can go and we can download. So don't worry about what is the development environment, testing environment, user acceptance, and general availability test, and so on. This one we can discuss more in-depth analysis part of the application security. So once again, software development life cycle. So after downloading this one, already this one is downloaded. So just you can go and you can install this particular thing. So just click on right click, and I'm keeping changes as a S. So actually already I have, okay, so 4.010 is there in my system. Can you see here? Wireshark 4.01064 is already installed. That means in my laptop already it is there. But what is the latest one? It's a 4.16. Would you like to uninstall first? Yes. So next, and click on next, 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 and finally finish. It will take a couple of minutes. So before going to install, what I will do, I will explain about little bit in-depth analysis, what exactly we have to do. So whenever if you want to do the packet capture analysis, as I said, we have to use the Wireshark analysis part. So first it is uninstalling my previous version, and later it will reinstall once again. Yeah, it will take a couple of minutes. By that time, I will explain theoretical part. So packet capture, in short, we can call it as PCAP. Okay. So now, what exactly in this Wireshark tool, how it will do, and what we have to verify in the each and every TCP IP layer wise. So as I said, we have the total 4 layers are there, part of the TCP IP. Whenever if you are, okay, so importing the packet capture, now in the application side, what exactly we will validate, because application contains the domain name. So that is nothing but DNS records. So here we can verify in the layer number 4, part of the TCP IP layer. Whenever if you are importing the packet capture, if you want to do the debugging or troubleshooting part, application layer wise, application availability, what type of DNS resolution it is happening, DNS record is configured or not, So that one we can verify part of the application layer. In the transport layer, what exactly we will verify? Okay, so here once again HTTP request, HTTP response, and what is the server code related to client, and what is the client side errors are getting. So those things also will verify authentication and everything. On the transport layer side, so already we discussed couple of protocols are there part of the TCP or UDP side in the transport layer. So here we'll see whether TCP three-way handshake is happening in between client and server, or source to destination, or peer to peer, where the exact issue is there. So for example, if I want to show practically once again, so I'll go to FortiGate firewall demo tool. So here I will click on this one. So I'll click on advanced. So here I will enter this one I have shown already previously one time where we are discussing about routing part. So couple of routing protocols we discussed like RAP, EAGRP, OSP, or BGP, static route, multicast route, dynamic routes. Hope you remember part of the network layer discussion. So demo and also demo. So this is the username and password. This particular firewall is available to anyone from anywhere, even including your mobile. You can access. It's a free of cost. There is no need to pay any money. So now, for example, maybe in the firewall, one of the alert is triggered. So part of the security dashboard, if you want to do investigation of that particular firewall, we don't know where is the issue. So in that scenario, now what I have to do, I have to go to the log on report option. So here we have forward traffic option is available, local traffic is option is available. All these options will be there. So just you can click on the forward traffic. Now, wherever the instant we received part of the source and destination, so we have to identify based on the filtering option. For example, take source address as 10.88.210.50 example only. So apply. So in the similar way, for example, destination, one of the attacker IP address. So attacker IP address, yeah, you can take example of this one. It's a public IP and apply. Example only I'm saying, okay. Now in between these two, okay, so I want to see what is the exact issue in between source and destination. Okay, now whenever the incident is happened, you can select that particular time filter is as well, which time that instant it's happened, when the attacker has done. So attacking part. So what happened at the application side, network side, okay, so transport layer side, and also finally network interface side. Once the end user is accessing any website or maybe sending an email or clicking on any retail websites or transferring the money in the HDFC bank or whatever it may be. These are all the practical scenarios. Okay. So you can filter the time as well. And after that, after applying this one, now I can go and I can download this particular, this is called PKF file now. So we have to select that particular packet. Now in between source and destination, this is source and this is destination. And you have download option is there here. So click on this download. Now packet time, this is called IP packet in between the source and destination. Now I am downloading the IP packet. So I want to analyze now packet capture analysis. Yeah, it will take a couple of minutes once again. So this is the way in the practical scenario. Not only that one, for example, maybe you are integrating logs to SIM tool, but logs are not reflecting. You are sending, integrating means sending here. You are sending the logs to SIM tool and SIM tool side logs are not reflecting. There also same thing, we have to the packet capture. And so why the logs are not reflecting or why the logs are not coming to SIM tool, we have to verify. All these things can be done by basically implementation team, but you should be aware of these things as well. Okay, so that is one thing. For example, maybe server side. Server side also you are integrating logs to SIM tool. But unfortunately, one of the Unix server logs are not reflecting the SIM tool. Now we have to go to the Unix server and we have to generate the TCP dump. And after that, we have to open the Wireshark and we have to do the analysis part. This is the way practically we can do the packet capture analysis part. And after importing these files, we have to go back to our Wireshark tool. So it is already installed. So just you can open here. Whatever file you downloaded now. So we have to import. So these are all the different types of adapters are there. So whatever adapter you can choose, you can choose. Right now you can see traffic is going on. Can you see here slopes are going on, traffic is going on. So one of the other adapter is loopback adapter and second one is called Wi-Fi traffic. In my personal laptop, there are two different types of traffic is going on. One is wireless traffic, whatever system I connected through Wi-Fi. In the similar way, adapter loopback. This is also part of the Wireshark. Wireless itself. So now you can click on the Wi-Fi traffic. I'm not importing any traffic here. So now traffic is going on. Okay. So here it will give color coding part. Couple of times it will give red color. Couple of times it will give yellow color. Couple of times it will give the ash color. Couple of times it will give green color and so on. According to the color also we can estimate, but don't say based on the color I will decide where is the exact issue. Okay. So I will stop it here. Okay, now you can see wherever the color it is showing as this one. So those places normally issue will be there. And also we can do filter applying also here, IP filter applying. Now we can see right now I don't want to discuss in-depth analysis this one. In future, wherever it is required part of the onboarding of the log sources or firewall topic side, there I will provide the deep in-depth analysis. Now, what is the topic we are discussing here? TCP IP layers. Whatever I said theoretically, it is matching the practically or not, we can verify now. So as I said, how many TCP IP layers are there?
4 layers.
4 layers. Yes, you are right. So what is the data format in the data link layer or network interface layer?
Frames and bits.
Yeah, now you can see. So first one, I selected one of the packet. So this one is called base 64 or hexadecimal code. So this is called as a payload basically. Now you can see frame here. So this is the frame it is going on. So whatever device or whatever or backend applications I'm using or whatever Google Drive I opened and Zoom I'm opening and I'm teaching something now, all those things, it will appear via packet capture analysis. So frame is a part of the data link layer. So this is matching Ethernet. Ethernet will fall under which layer? Ethernet will fall under which layer?
Network layer.
Network layer.
Network layer. Data link layer only. Ethernet and all Ethernet interface nothing but data link layer only. So frame and Ethernet both are belongs to network interface layer. So based on, I will go back. So go to our cyber security. So here network interface layer, these two, data link and physical. So these two combining together we can call it network Ethernet layer. Okay. So this is nothing but network Ethernet layer. Okay. So our data link layer, whatever. If it is voice reference model, go back to Wireshark now. So first thing is matching. Next one is internet protocol version 4. So where this internet protocol version 4 will fall under?
Transport.
Transport.
Network layer.
Network layer. IP protocol version 4 it belongs to. Okay, so it is a network layer. So now network layer is also called as network layer. Internet layer, yes. So that is okay. So here internet layer or network layer. So here, that is what I said, IP packets. Now go back to Wireshark. User datagram protocol, UDP.
Transport layer.
Transport layer, that's right, transport layer. So transport is transport only. So according to our TCP IP layer, finally data. So data will fall under which layer?
Application.
Application layer. So now you got it right. So these things is a part of the TCP IP layer. It will not give like so OSI reference model. Always packet capture analysis can be done using the TCP IP layer analysis only using 4 layers. Okay. Now whenever any issue will come, so now we have to go and you have to read all these and you have to understand. If you want to go and read all this, first of all, you should be aware of the 2 different types of things. One is called TCP packet. This one also I have shown last time, and also IP packet. So in-depth analysis part. So TCP packet architecture diagram and also IP packet architecture diagram. Then only you will understand about what's going on in that packet capture analysis. If you don't know about these analysis or this packet thing in your mind, you can't understand what's going on. So this one is IP packet, and this one is this also IP packet. So this is also okay TCP packet. So this is the TCP packet. So TCP packet contains 32-bit number. This is already we discussed part of the segmentation when we discussed about transport layer. So every segment has the source port and destination port, and also sequence number and acknowledgement number. Here they given wrong basically. This is not destination port. This is called the sequence number. So this is acknowledgement number and data offset reserved, and TCP flags are total 6. Like yesterday we discussed about sync, acknowledgement, finish, urgent, push, and finally reset. And so this is what you should understand in the similar way IP packet. So IP packet is this one. Version of the IP packet, internet header length, type of the service, total length of the packet, and IP identification. IP flags. IP flags are 3, but these flags are not that much important as compared to TCP flags. And fragment offset, time to live. So protocol related to IP, header checksum related to IP, source IP, destination IP, and padding. So now these two, so one is TCP packet, second one is IP packet. Now go back to Wireshark. So especially on the internet protocol, same thing they will give. Version number 4. So go back to now our IP packet. So version number 4. And the next one is header length, nothing but internet header length. Next one is so type of service, total length. So type of the service here, and the total length of the packet, total length of the packet. Next one is identification. So identification of the IP packet, and the flags. So these are all the flags. So flags here, and fragment offset, and after that time to live. So TTL, that is called how much time that packet has sent and it is received in between source and destination. And protocol, whether it is using TCP protocol or UDP protocol, and header checksum. You got it right what I'm saying now?
Yes, sir.
Yeah. So that means you should compare the, that means you should know about this thing, entire thing in your brain or mind, then only you can do the analysis. If you don't know about this packet related to IP and also TCP, you can't analyze the packet analysis. That's what the final conclusion.
Top portion is IP header means, right, sir?
Sorry?
The IP packet, how can you understand the IP header or top of the elements of the IP header?
So everything is IP header. Up to version 2, destination IP address is called IP header, and options and pairing is called as a data or payload.
The codes which are present in the analysis one, do we need to remember those?
No, this one we don't need to remember. Just you can remember these things only. That's what I said. Just only remember this packet and TCP packet. If you know about this one, then you can go and you can analyze these things are very simple way. What's going on? For example, maybe synchronization flag is missing. So here anyway, TCP three-way handshake is not there. UDP protocol it using. Maybe this is live streaming, or maybe some other maybe video call or audio call. Because I'm making right now audio session, maybe using this one. So this is related to UDP. Okay. Now something is missing here and the payload related issues are occurring. Then we have to analyze, okay, issue is there in the transport layer, or issue is there in the application layer, or issue is there in the network layer, or issue is there in the network interface layer. Finally, we can go and we can coordinate with respect to application team or network team, or else physical data site engineer, whoever is a part of the data center. This is the way how we can fix the issues.
So here the UDP protocol is there since that we have checked some status as unverified. What
Yeah.
about TCP?
TCP is not there because this connection, whatever it is established, it's using UDP.
No, no, on the top we have one more, right? Which is lavender color.
Yeah, this IP protocol.
Not in this, in the top of menu where the packets data is present.
Top
There
menu.
are two black holes.
This one you mean?
In between that we have a TCP one, right?
Yeah, so that is what whenever you are selecting this one, it will change. So if you are selecting this one, this is the packet, and if you are selecting this is the packet, if everything is like a packet only. So each and every row, this one it is representing is a packet, because packets are going continuously. Data transmission happen continuously. So this is one packet, this is one packet, this is one packet, and so on.
No, no, I'm asking about the checksum. Since it is a UDP, we don't have acknowledgement. That is the reason why it is unverified.
Yes,
Is
that's
it?
correct. Yeah, that's right. Yes, you are right. Yeah.
Okay. So I actually, can you show this TCP one also?
Yeah, TCP you can see here. So already I clicked on this one. Your transmission control protocol and source port and destination port and stream index and TCP segment and sequence number and acknowledgement number and acknowledgement number. In case it is showing like a sequence number and acknowledgement number and flags is unverified. In case flags is showing is like unverified. Okay, so right now it is acknowledgement flag. Nothing but feedback is coming in between. So client and server. If it is showing like unverified, maybe in between client and server, one of the flag is missing. So it is a client side issue.
Based on the code.
Yeah, this is the way you have to do the analysis part. But don't worry, just what I'm trying to say here. Now I'm trying to say here, if you want to do the packet capture analysis using Wireshark, it will give the TCP IP layer analysis only. Okay, so that you can remember each and every layer, what exactly we have to do. As I said, on the application layer side, application HTTP request and HTTP response, and what is the authentication code? Is there any codes are there part of the application side or data? Okay, here it is called data. So whether DNS record is published or not, you have to verify in that one. If it is a transport layer, TCP three-way handshake, all the flags are enabled. So which flag it is missing, it's unverified, and so on, we have to verify. In the network or internet layer, we have to see whether packet is retransmitted or packet is dropping. For example, here in the red color, so here maybe packet issue is there. So we don't know, we have to verify that one. So packet is retransmitted or packet is allowed or packet is denied or packet is blocked. So these are all things can be done by packet side in the network layer. In the network interface layer, maybe in the data center or maybe in the data link side, frame issues are there, or physical cable connectivity issue, loose connection. For example, you are connected Ethernet interface using the optical fiber communication or maybe through Ethernet RJ45. Any loose connection is there, obviously. So it will not communicate and it will not data can be transferred. So these things can be verified. And finally, where is the issue we have to understand. So that overall analysis can be done by which tool? Which tool?
Wireshark.
Wireshark. And one more thing here, and here also filtering option is there. Couple of interviews, they will ask like, do you know how to do filtering in the Wireshark? Do you know how to do filtering option in the Wireshark? So here there are so many options will come. For example, IP. This entire question by the way. IP.addr equals to equals. So how can you filter out IP address in the Wireshark? Okay. In the similar way, how can you verify HTTP request? How can you verify DNS request? How can you verify HTTPS request? So you can do the filtering option and also you can do DNS option. There are so many things. Basically, whatever protocols we are using part of the entire communication in between source and destination, all those analysis we can make it. So it will give a lot of things basically, not only that, but it will give so many statistics and also it will give the packet capture analysis part, everything. So this just one introduction part only. Separately, I will take this session when we are moving to networking side or else onboarding of the log sources side. There we can do the practical scenario. But you got some basic, right?
Yes, sir.
Yeah. So What is the interior question? Maybe you can expect. Do you have any experience on Wireshark? In the Wireshark, what exactly you will do? Okay, so that is the interior question. Okay. So as I said, in the transport layer side, TCP three-way handshake is completed or not. In the similar way, TCP two-way handshake completed or not. So, and also TCP five-way handshake, TCP flags are enabled or not, and flags are verified or not. All those things, everything, entire packet we have to analyze. In the same way, in the internet layer or else network layer, we have to verify packet is a traverse or packet is delivered or packet is retransmitted. When you say retransmitted, so first time maybe data is dropping, second time it will try to reconnect once again. So that is called packet retransmission part. Packet is allowed, and finally packet is blocked. So these things can be done part of the internet layer. Not only that one, as I said, so whatever IP packet, each and every packet thing has to verify. Along with this one, I have to add one more thing here. What is the payload analysis part? Payload. Okay, that is on the internet layer. On the network Ethernet layer side, is there any frame issues? And also, is there any Ethernet interface related issues? And is there any media related issues when the packet is traversing via media? And finally, physical connectivity issues. So we have to verify. So these four layers, each and every layer can be done using the Wireshark part. So these things we can verify. Now, as I said, you should be aware of the Wireshark filtering as well. So why we have to use Wireshark filtering? So to filter out easily, because there are so many packets are going on. It's a real-time monitoring part. Right now, whatever I'm showing, because I stopped the packet capture. Okay. So if I want to continue once again, just filter out, you can remove. And so you can take and you can analyze all these analysis part. Okay. So this is the way one thing. As I said, not only real-time monitoring part, even we can do the manual analysis without real-time as well. So for example, I downloaded the FortiGate firewall packet here. So now I'm going here and there. Don't get confusion here. First, whatever Wi-Fi connected, and I went and finally I captured the packet. For example, you download the PK file from the firewall, or maybe a TCP dump file from the server. Now what we have to do, so wherever the file is downloaded, just you can go here, file import or file open directly. File open here, and whatever file is downloaded, part of the respective downloads, you have to select that file there. Okay, so that is on the manual analysis part without real time. Okay, most of the case we'll do manual only. So go back. So filtering option also we can do. Filtering option is based on the different types of protocols like IP filter, DNS filter, HTTP filter, HTTPS filter, ERP filter, MAC filter, and so on. There are so many options. Please go and play this one. So that is the thing overall on the Wireshark. Okay, so this basic introduction only. Okay, next one. Interior question also I will write right now. Do you have any experience on Wireshark? Okay. In Wireshark, what exactly you will analyze? So this is the way we can do. And when is our practical scenario, as I said, not only on the implementation side, whatever just now I said, so everything is like implementation side. For example, SIM tools, not SIM tools. In the SIM tool side, we are onboarding the logs. Whenever if we are saying onboarding, it is like we are integrating or we are sending the logs to SIM tool. That is like implementation side. So maybe firewall you are implemented, but unfortunately, even though you are implemented firewall, I'm not able to access couple of websites or application as a developer. Now you have to do the Wireshark analysis part in between my end user IP address to whatever website I'm not able to access as a developer part. Okay. So for example, take you are implementing NADS NAPS tool and you have done implementation using inline method or promiscuous mode. So thereafter, I'm not able to access couple of applications or malware related couple of files. Now, once again, as a implementation guy, you have to go and you have to verify where is the issue. So these are on the implementation side. As investigation side also, as I said, flooding category of the attacks, it will appear, spoofing category of the attacks, and also malware category of the attacks, it will appear, any abnormal or malicious suspicious activities happening. And if you want to verify, so there also as L3, most of the cases, this Wireshark analysis can be done by L3 level. Okay. If they want to do reverse engineering part and threat hunting capability, malware analysis capability, L3 team, they will use most of the case Wireshark tool. Okay. So that's all about overall introduction part. Coming back to how to answer this one. Yes, I do have experience on the Wireshark. So yeah, normally whenever any security incident investigation related to abnormal or malicious or suspicious activities happening, I used to do the Wireshark analysis. That is the first scenario. On the implementation side, couple of scenarios like if I implemented firewall in case couple of websites are not accessed by the developers or HR team or legal team or network admin team or Windows team or Linux team, there I can go and I can do the Wireshark analysis. In the similar way, if I implemented web application firewall and all the WASP top 10 category of the attacks I configured, but unfortunately, couple of websites, once again, end user is not able to access. In that scenario also, I can go and I can troubleshoot using Wireshark. Finally, in case logs are not reflected in the same tool, I will do the packet capture and I will analyze using TCP preference model. So these are the use case or practical scenario. Normally, I will work on the Wireshark analysis. In the Wireshark analysis, what exactly I will do after doing the packet capture import from the respective where the issue is identified in between source and destination, I will do the packet capture and that PCAP file I will bring and I will import or I will open in the Wireshark tool. Then as per the TCP IP layer analysis, in the application layer side, is there any issue existing? In the internet layer, is there any issue is existing? In the transport layer, is there any issue is existing? In the network interface layer side, is there any issue existing? For example, application side, like a client side issue or server side issue or DNS record issue or availability related to application side. In the similar way, internet layer side, packet why it is retransmitter or packet why it is blocking or packet why is allowing or blocking. So on the transport layer side, whether UDP checksum it's completed or not, it's verified or not. In the similar way, TCP protocol side, is there any TCP through handshake is completed in between client and server, and whether all the flags are successfully verified or not. In the network interface layer side, I can go and I can check the so how the data can be if data is transferring in between source and destination using frames, and also is there any cable connectivity issues are occurring in the network interface layer side, I will verify. So this is the way how scenario to scenario or use case to use cases I am working on Wireshark tool in my organization or in my current roles and responsibilities. That's all. Okay, so this is what we have to explain, guys. You can take one example also practical, and you can give example, maybe whatever I said, couple of example, you can take one practical and you can explain. That is called real time. Everybody will say real time, real time, real time. What is real time? This is called real time. Okay. So now I want to explain about anything I missed out. Yeah. TCP packet. So TCP packet, as I said, so I will make this one as a snipping tool. I will go to snipping tool here. So this is the TCP packet. So I'll copy paste that one in our diagram, because otherwise you will not remember. I know that. So I will reduce this size. So I'll make it okay in correct way. So later after this class, in the similar way IP packet. So that is about IP packet and TCP packet. So these analysis can be done using Wireshark under the part of the TCP IP layer packet capture analysis part. Okay. Yesterday, did I say about router and switch and hub? So we discussed about only switch and router, correct?
And also differences also.
Yeah, differences also. But did I say about what is meant by an intelligent device versus non-intelligent device?
I didn't explain that actually.
Yeah, I did not explain that one. Yes, I do remember. So I'll explain about intelligent versus non-intelligent. Router and switch are intelligent device. And why I'm saying this one now, in future we'll discuss about ARP poisoning attack, MAC flood attack. For those scenarios, you should know about what is meant by router and switch is an intelligent device. Why not hub is not an intelligent device? But hub is not an intelligent device. So go back to our draw.io. I have to open once again. So just will keep like a switch, and I will save it this one in my documents. Create. So example, I will go to switch. I will take so this switch or router, whatever. I will take one computer. So this is computer. I will take one router as well. So this is router. I will take one server, Cisco server. So this is file server. I will take one printer is there. Okay, what he thinks. There is no name. Okay, wireless LAN. Okay, so these four I am taking now. So one computer and also one is access point. Access point is nothing but whatever Wi-Fi we are getting through access point, we'll get it normally. For our PAN, nothing but personal area network, will not use access points. So everything like a router only through we'll get the Wi-Fi. But in our enterprise level organization like airport or bus stations, or maybe so railway stations and other public areas, not only in those public areas, even our organization level as well. So maybe TCS, Infosys, or Wipro, whatever company we are choosing. So we have to deploy the access points. Okay. So through that access point, for each and every access point, we have to assign one of the dedicated ID that is called single set identifier or SSID. That we will not call it as a Wi-Fi now. Basically, we have to call it as a SSID. Now I will make the connection establishment for these using a LAN. So this one of the cable connectivity, and 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 finally this one of the cable connectivity. Now, so end user, so this is computer. End user wants to access one of the file from the file server. End user wants to access one of the file server from the file server. So that file server is centralized file server where all the files can be deployed, and based on the team wise, we can give the access wise permissions or granting part. So now maybe he needs one of the project file. So this end user is a part of maybe example take developer, and he need one of the project oriented file. He have to copy that file. Okay. So obviously has to connect VPN, or maybe if it is remote work, he has to connect VPN. Otherwise, he is in office. Directly, he can connect through LAN or Wi-Fi. Now that particular request, whenever he is connecting, as I said previously, first always that request will go to access switch. Now access switch, what exactly it will do? It will broadcast that request. Router and switch will broadcast the request to whatever devices are connected in the entire LAN. What are other devices are connected in this particular LAN? One is access point, second one is router, and third one is file server. Okay, so this is called AP, access point, and this is router or router, whatever. So this is called file server. Now, whenever the end user wants to access any file, he will send the through FTP protocol or through SFTP protocol. Obviously, we have to use SFTP protocol. He wants to copy the file. Now that request will go to switch, and switch will broadcast whatever devices are connected in the entire LAN. Now that request will go to broadcast means connecting to multiple system, whoever is a part of the LAN. So here broadcast. For example, watching of the any sports, that may be kabaddi or cricket or maybe so tennis and so on. So they will broadcast right to online streaming. So same thing here, all over the worldwide, how they are streaming or how they will broadcast to each and every person. So he is requested for the subscription, and so then finally wants to watch the movie or whatever, cricket or movie or whatever it may be. So they will broadcast similar way. So now that request, when the end user or developer wants to access the project file, that request will go to whoever is connected part of the LAN, that is called access point, router, and file server. Now who has to respond back? Who has to respond back?
File server.
File server has to respond back. So now, so file server will respond back. Okay. Now switch will validate whether the correct person is sending the file or not. Okay. So whether whatever is requested, that particular file server itself is request is coming as incoming file, it will validate, or router also it will validate. Then finally, it will, whoever is requested, it will transfer the file through FTP and SFTP. So that is called is an intelligence will be there. Okay, clear now. So for example, I'm removing this one now, connections. For example, access point is responding back. I'm the file server. You can take the file. What switch will do now? Whether switch will accept it?
It will deny the request.
Exactly. Switch will deny the request, stating that you are not a correct person. Maybe it will like think like a suspicious activity or abnormal activity. It will deny it. Okay. So this particular process, we can call it as an intelligent device. Switch and router is always an intelligent device. But coming back to here, I will take hub now. Take example, this is hub. Now hub is it is a non-intelligent device. Now same thing. So now end user is requested one of the file. Now access point is responding back. Whether hub can accept the request or deny the request.
It will accept the request.
Exactly. It will accept. Yes, it will accept the request and it will respond back to the end user. That is false information basically. It is not a real information. That is called non-intelligent device. Initially, whoever is invented, hub is invented first, and after that, okay, so respect to router and switch is invented. Okay, so that is called basically intelligent device versus non-intelligent device. So for example, simple. So now so many people are joining this class. I'll pinpoint Priyanka or maybe Naveen or maybe so Chiranjeevi and so on. Whenever I'm calling someone, they will respond back. Maybe maybe I'm taking wrong information. Okay, so someone is responding back wrongly. Maybe I'm hub now. I'm not taking the proper information whoever responding back. But so whoever is responding back, I'm accepting it in the correct way, correct person. Now I will act like a switch or router. Okay. So that is about overall intelligent versus non-intelligent device.
That means no one can use the hub right now.
No, we are not using hub anymore now. It's already obsolete.
Outdated. Yeah, okay.
It's outdated or obsolete or legacy.
So, in if at all we are using in a school environment to all the labs and all, there we can use hub, right?
There also, so according to point connections, we can use, not for the distributed environment like a broadcast, unicast we can use.
1-to-1.
Yeah, so 1-to-1 like unicast. For unicast side, yes, we can use, not for the broadcasting side. Yeah. You know, right? What is mean by unicast? So dedicated to one particular
1-to-1.
Yes. One system, only one printout. There you can use hub. Okay. Yeah. So that's all for today, guys. Tomorrow I will start classes of the IP address. It's a very, very important. And please don't skip tomorrow class.
What time, sir? Tomorrow?
Tomorrow, shall I take 2 sessions or 1 session?
Better to.
Yeah, because we are lagging too much here. So only I completed 2 topics. One is OSI and second one TCP.
Yes, sir, I can say that, sir. Yes, sir.
Yeah. You completed almost 12 to, I think 11 to 12 classes, but still we are in only second topic. Better maybe tomorrow I will take 2 and the day after tomorrow I will take only 1.
Okay.
Okay, guys, then tomorrow 9 a.m. morning session and evening 7 p.m. Okay, evening session.
Okay.
Okay.
Sir, excuse me, sir.
Yeah, please.
Just a second, sir.
Yeah, please.
Sir, you said that these data packets, I mean the Wireshark.
Yeah.
If the suppose you are making transmitting from SIM tool to, if the logs are not providing to SIM tool, we need to do a analysis using a Wireshark.
Yes, correct.
But actually the logs, as you said, it is inside the laptop, right? We need to check out whether the agent is working or not.
Your voice is chopping, unfortunately. So in between, yeah, see, basically, so there are different types of log integration methods. So one log integration method is called as a collector agent. Second one, we can call it as syslog server method. Third one, we can call it as flow collector method. Fourth one, we can call it as a WMM method. Fifth one, we can call it as a MSRPC method. So next one, we can call it as a cloud connector. And next one, we can call it as a API token method. So whenever or whatever integration method we are using, for example, as you mentioned, one of the Windows laptop logs you are integrated to SIM tool. But most of the cases, Win Collector agent is not recommended one. Why? Because all the employee related logs we can see in the Active Directory domain control if it is authentication and authorization failed, and all malware category of the end user we can see part of the EDR, all websites related requests. So allowing and blocking like whitelisting and blocklisting we can see part of the proxy, and also all email related phishing email related logs we can see part of the email gateway. Any voice top 10 category of the logs we can see part of the web application firewall. Any flooding or spoofing category we can see part of the NIDS and APS. So yes, even though couple of vendors like Splunk or IBM QRadar or ELK tool and Securonix tool, and these vendors they will say like you can install the agent on each and every end user machine. Basically, how many agents we have to install? We have to install antivirus agent, we have to install EDR agent, we have to install the DLP agent, we have to install the proxy agent. So many agents if you are installing, finally our system will be crashed or damaged, and hanging related issues will occur. Anyways, I will come back to your question. For example, we install the Win Collector agent to integrate my laptop logs related to Windows 2 SIM tool. In that scenario, first and foremost, what are the different types of troubleshooting steps we can do? First, we can see whether that particular agent is a wake up or not, whether it is active or inactive, and what is the port number it is communicating through SIM tool, whether it is 8081 or 9093 or 443 or 8443. So these are all the most of the cases we can use for the collector agent log integration method port numbers. And second one is what is the status of the agent, inactive or unknown or sleeping or wake up or active. After verifying this one, still logs are not reflecting, and also in the SIM tool, then in between your Windows laptop to SIM tool, so we have to do the packet capture. Where we can do the packet capture now? So we can go to firewall and select source as your Windows laptop and the destination as your SIM tool IP address, and so select that particular packet capture file and download the PCAP file. Then you can go to Wireshark and you can do the analysis part. So this is the way, step-by-step process we have to take care based on which logs or logs we are integrating. Hope it's clear.
Yes, sir.
Yeah, don't worry. All these are in future topics. Basically, it's implementation of the SIM tool. Don't worry. So I will explain in-depth analysis in future again.
Okay.
Okay. Yeah. Any other? Okay, guys. Then thank you so very much, and thanks for joining. And see you tomorrow at 9 a.m. IST. Good night.
Thank you, sir.
Thank you, sir.
Thanks.